Welcome to the deep dive. Today, we're launching into something pretty exciting, actually. It's where adrenaline meets engineering. Zipline safety.
Yeah, we've been looking at some really interesting materials, things that raise some important questions.
Definitely. So we thought it was time to really explore them, get into the details.
Absolutely. And we've got quite a mix of sources here. There's a critical analysis focused on emergency brake standards
Right. And then there's this critique of digital waivers, how they're used.
and a YouTube video, too, very direct, from someone who seems to know a lot about Zipline braking systems.
So our goal today, our mission, if you like, is to really unpack what makes a zipline safe and, where the potential problems might lie.
We want to get into the engineering behind it, the risks that maybe aren't so obvious.
And hopefully equip you, our listener, with the knowledge to be, well, a more informed participant next time you're thinking about clipping in.
Because, let's face it, zipping through the air is a huge thrill. But that excitement really should be backed up by understanding the safety side of things.
Okay, so let's start untangling this whole emergency braking situation. One of our sources, that critical analysis, it really digs into the ASTM F2959 standards.
Right, ASTM International sets these standards, and F2959 is specifically for zip lines, challenge courses, that sort of thing.
And this analysis honed in on one particular requirement, didn't it? The need for emergency brakes if speeds go over 6 miles per hour?
Yeah, which is also something discussed in the ACCT guidelines. That's the Association for Challenge Course Technology. They set industry guidelines, too.
So 6 miles per hour, what was the issue there?
Well, what's really interesting, or maybe concerning, is the argument that this 6-mile-per-hour number, it sounds specific, but it might not be based on comprehensive data. Meaning the analysis suggests it wasn't necessarily derived from studying all the different things that can actually affect how fast someone arrives at the end.
Right. It points out some pretty big variables that aren't maybe fully accounted for, like the environment.
Exactly. Think about temperature swings. A cold day makes the cable tighter, potentially faster. A hot day, it sags more, maybe slower, maybe other issues.
And the standards fix 6 mile per hour doesn't really flex with that reality.
That's the argument. The same zip line could behave very differently day to day, hour to hour, based on the weather.
And it's not just temperature. The analysis also brings up rider weight.
Which makes total sense. A heavier rider carries more momentum. They're likely to arrive faster.
So the critique is that the standard perhaps isn't clear enough on how designers must factor in that full weight range when setting up the braking.
Yeah, it leaves you wondering how operators are supposed to consistently manage that, with all these changing conditions and different people riding.
The analysis also mentions wind, humidity, even altitude, all things affecting speed.
It paints a picture where just relying on that 6-mile-per-hour trigger might give a false sense of security.
And here's something that really stood out to me from that analysis. The reported increase in zipline accidents, something like 15 per 100,000 participants.
Yeah, that number does make you pause. It puts the whole discussion in a different light.
It really does.
And the analysis even brought up findings from Petzl, the climbing gear company.
Yeah, they make good stuff.
They found their standard pulleys can reach speeds equivalent to 0.95. That's nearly the force of gravity just from the pulley system itself. Significant speed potential.
Okay, so speed is variable, potentially high. Now, the critique also looks hard at how emergency brakes are reset, specifically the reliance on manual resets.
Right. It brings up entropy, the idea that things tend towards disorder and, well, basic human error.
Why is that such a big deal here?
It really boils down to reliability. If you're trusting a person to manually reset a critical safety system every single time perfectly.
You're introducing a weak link.
Essentially, yes. People get tired, distracted, they can make mistakes, and repeated manual actions can wear things out too.
The analysis made a really sharp comparison to roller coasters.
Exactly. You wouldn't have someone manually resetting the brakes on a coaster run after run. That would seem crazy. Right?
Yeah, totally. Those systems are automated for safety. It's expected.
And that leads to an ethical point the analysis makes.
Yeah.
Shouldn't engineers design systems that are inherently fail-safe? Systems that don't depend on someone remembering to do something or the rider having to compensate.
Safety built in, not bolted on or relying on human perfection.
Precisely. The call is for engineering solutions that actively account for all these dynamic variables, temperature, weight, wind, and favor automated safety.
Okay, so that's a strong message on braking standards. More engineering, less reliance on simple thresholds or manual actions.
That sums it up well. Now let's pivot to the second source, the one critiquing digital waivers.
Ah, yes, the waivers. This piece really challenges the idea that just getting a signature on a screen protects operators completely.
It doesn't mince words. It even suggests that advising operators to rely solely on waivers could be seen as grossly negligent.
Strong language. So the core argument is
That a waiver doesn't let an operator off the hook for meeting the fundamental safety standards. Those ASTM standards we mentioned, F2959 for brakes, others for inspections, weight limits, plus the ACCT guidelines on operations.
Waivers don't replace those?
Not at all. The critique is clear. If an accident happens because those standards weren't met, the waiver probably won't shield the operator from legal consequences.
it mentioned people often sue specifically based on failure to meet those standards.
Exactly. And it also touches on regulatory issues. Ignoring safety standards could lead to shutdowns by the state or even insurance companies refusing to cover claims.
So the waiver isn't this magic bullet some might think it is.
Far from it. And the critique brings us back to those engineering risks we just talked about.
Like temperature variations, delta T, they called it.
Yes, delta T affecting the cable tension and also rider mass. It argues that waivers often just gloss over these critical physical realities.
Why is that connection so important?
Because, like we said, temperature changes speed. It can lead to hitting the brake too hard, or worse, maybe lighter riders not even reaching the platform, getting stranded.
And rider weight affects the forces on the braking system, right? And what happens if someone does get stuck?
Absolutely. The critique points out that typical waivers don't explain how your weight might change your stopping distance, or what the plan is if a retrieval, is needed midline.
And it mentioned ACCT standards actually require specific backup braking for high-speed lines.
Yes, redundancy, something you rarely see mentioned in a standard waiver form.
So the message here seems to be, focus on preventing accidents by following the rules, not just on limiting liability after something goes wrong.
That's the crux of it. Prevention through compliance.
The critique also got into the legal limits of waivers themselves.
Right. It clarified they generally only protect against claims of ordinary negligence, not gross negligence, not reckless behavior.
And enforceability varies. It mentioned different states.
Yeah, California, Florida, New York were examples. How waivers hold up can really differ, especially with serious injuries or if minors are involved.
So definitely not foolproof protection.
Not by a long shot. But the main takeaway from this source is crystal clear. Compliance with safety standards, engineering, inspections, training, that's the real way to manage risk, not just the waiver.
Okay, very clear. Now let's bring in the third piece, that YouTube video. Zipline 101, gravity braking.
Right. The presenter there has a very, very strong opinion about gravity braking systems.
Strong is putting it mildly. He actually said, gravity is not a braking system unless you spell it with an E.
He's definitely not a fan. His argument hinges partly on comparing it to what he sees as a better system.
The one at Park City.
Yes. The friction braking system there, using a spring array, he claims it has a 23-year track record with 0 braking-related accidents.
And he contrasts that 0 with the overall Zipline rate we mentioned earlier, 15 per 100,000.
And also contrasts it with roller coasters, which he cites as having a much, much lower rate, like 1 accident per 16 million rides. It's a dramatic comparison.
It really is, highlighting the potential difference systems can make.
Which is why he pushes viewers, listeners like you, to ask operators very specific questions about their braking systems. Don't just accept gravity braking as an answer.
So what are his specific issues with gravity braking? He mentioned temperature again.
He did. Colder temps, the cable contracts, potentially making the braking zone shorter, maybe harsher.
And hotter temps.
Cable expands, sags more. He suggests this could mean lighter riders might not have enough momentum to even reach the landing platform. They could get stranded.
Which brings back that risk we talked about, later riders getting stuck.
And it reinforces that whole point about environmental factors impacting safety, something a simple gravity system might not inherently adjust for.
He also highlighted risks for different weights again, didn't he?
Yes. Heavier riders, maybe over 150 pounds, could face more abrupt stops. Lighter riders, maybe under 100 pounds, face that stranding risk.
Which, if they get stranded, introduces the potential for collisions if another rider is sent too soon.
Exactly. It requires extreme vigilance from the guides.
And he comes back around to that 6 mph rule, too.
He does, emphasizing the industry requirement for a separate, automatically resetting emergency brake on lines faster than 6 mph.
His core point seems consistent with the other sources then.
Very much so. Relying on gravity alone or on humans to intervene perfectly every time runs counter to basic safety principles because of entropy and human error.
So it really feels like all these materials are pointing in the same direction,
Yeah.
away from simplistic approaches towards more robust engineered safety.
That's a great summary. Systems that account for variables and minimize reliance on human action at crucial moments.
Okay, so let's recap the key takeaways from this deep dive. First, that 6 mph threshold for emergency brakes. Maybe not enough on its own.
Right. It doesn't seem to fully capture the impact of things like temperature, wind, and, importantly, rider weight.
Second, those digital waivers, they're common, but they are definitely not a substitute for actually meeting safety standards.
Absolutely. Compliance with ASTM, ACCT, those regulations, that's what truly matters for safety and liability.
And finally, we heard a strong critique of gravity braking as a primary system.
Yeah. Highlighting its sensitivity to temperature and weight and underscoring, again, the need for reliable, often automated, emergency braking backups.
The big picture message seems clear. The industry needs to lean into engineering-driven safety, really commit to meeting, maybe even exceeding, the current standards.
For a safer experience for everyone. So for you, our listener, when you're thinking about your next Zipline adventure, keep this stuff in mind.
Yeah, don't be afraid to ask questions. Ask about the braking system. Ask how they account for different rider weights or changing weather.
It's exactly. Be an informed participant.
And maybe here's a final thought to leave you with. If something seemingly straightforward like ziplining involves this much physics, engineering, and human factors to be truly safe, what other activities, things we maybe take for granted, might deserve a closer, more critical look from a safety angle?
That's a really interesting question to ponder.